Hi, everybody. Welcome to the last talk of the conf, like Brett said, and thank you for being here. I am Nick Fagerlund. I'm that guy. I work at the docs team at Puppet, and I've been there for about 5 years. And I also gave a talk at PuppetConf 2013 that was inspired by Gary Bernhardt's legendary lightning talk called WAT, which I encourage you to watch, except for the fact that there's some kind of like DDoS buttholes on the loose today, and his site is one of the ones that went down, along with GitHub and Twitter. So as soon as that comes up for 5 minutes that you need to watch the talk, give that a look. But today's talk is kind of a sequel to that 2013 talk I gave that was kind of inspired by the joy of confusion and things that make you say, what? Or maybe more than a sequel, it's more like the where are they now captions from the end of Animal House. But here's what we're going to talk about today. We're going to look back on some of the fucked up malfunctions that I managed to find while I was trying to comprehensively document the Puppet language. We're going to revisit some of the worst of those and show how we fixed them in Puppet 4. And my goal in doing this is twofold. One is that it's another chance to kind of point and laugh at some goofy shit, and I'm not going to turn a chance to do that down. But two, the language changes we made in Puppet 4 were kind of an incredibly big deal, or at least I think so. I think you've heard about some of the headline features probably, but I honestly think that showing how we've cleaned up some of the language's inconsistencies and kind of nightmare zones can actually be a better explanation for why we did so much of the stuff we did in that last big release. And so I've split this talk into 3 sections. First is stuff that was fundamentally busted in Puppet's underpinnings, and which interfered with your work on almost a daily basis. Secondly, stuff you didn't run into as often, but which was just so ridiculous that it kind of undermined your faith in reality. And finally, stuff that actually worked fine, but was just an incredible bummer to work with, and is now not. So, let's get started. Since this talk is about justifying why we made such big and disruptive changes in Puppet 4, which I'm sure have delayed some upgrades for some of the people in this room just because there's kind of a lot of stuff to think through. Because of that and the bigness of it, the first few things I want to talk about were huge fundamental problems in the language, which just couldn't be fixed in an incremental way. They weren't edge cases, they were kind of core to your experience, and you'd frequently run into weird new ramifications of them. They caused terrible inconsistencies and unpredictable behavior, and they made your Puppet code harder to reason about, and they are no more. Here's a little pop quiz from the Puppet 3 era. What do you think this code does if you declare the profile Apache class? Does it include the class named Apache, or does it literally do nothing? Yeah. Answer is B. It actually includes a class called Profile Apache from inside a class called Profile Apache, so nothing happens. So how about this variation? Does that declare the class called Apache? Or does it explode? Yeah, it does the exact same thing. It tries to declare Profile Apache a second time, but because declaring a class a second time is not allowed with the resource-like syntax, it just blows up and gives up. The problem here is that include Apache in prior to Puppet 4 didn't actually mean include Apache. It meant try to include a bunch of other random stuff, but if none of it works, eventually include Apache as an absolute last resort. Starting with a child of the current namespace called Apache, a child of the parent of the current namespace called Apache, and moving on from there. Why do I have a pointer up there? Eventually ending at top scope once it has exhausted all intervening scopes. This was called relative namespacing. It sucked. It especially sucked if you were trying to use the roles and profiles method, since the whole point of that is to have a bunch of wrapper classes named profile something, where something is the name of the class you're trying to work with. And the workaround that we eventually learned, everybody eventually kind of learned independently, was to almost always put 2 colons in front of a class name, like that. But you don't have to do that anymore, because that is completely fixed in Puppet 4 and up. I feel like I've surprised a few people recently by saying that. You just don't have to do this anymore. It's so good. That raises the question of where relative namespacing even came from. That was an old behavior in Puppet. Like the way Puppet looked up class names predated modules, and it predated a whole bunch of other really basic features in Puppet. And in the beginning, I guess we thought it made more sense for name resolution to work the way that it does in Ruby, where in Ruby, having a local short name for a class is fairly important. Like you're down inside, like 3 modules deep, and you want to refer to a sibling class to make a whole bunch of objects, and you can use a short name for that. Puppet isn't like that at all. It turns out that everybody just uses the full name of a class all the time because the full name of the class maps to its position in a module thanks to the module autoloader behavior. And so this behavior that was basically a guess about how people would organize reusable code that we guessed before reusable code even existed in any meaningful way ended up causing daily havoc for pretty much most of our users. It's one of those weird emergent things from my system that builds up over time and can only be fixed with a bit of a big bang. Next. A really common thing to do in Puppet is a basic if statement where you're trying to do different things depending on whether an expression is true or false. And you usually want to base that decision on facts, which are built-in variables with info about the node you're trying to manage. Here's an example of some of those facts, just useful stuff about the node in question. What used to come up all the time, though, was that someone would notice a fact with a Boolean true or false value, like a fact called isVirtual. And they would try and do an if statement based on that, and then they would be really surprised to learn that literally every one of their bare metal nodes was actually virtual, and it left everybody kind of wondering if they were seeing the matrix. And it turned out that this was happening because the isVirtual fact is never actually false. It's only ever false. Because all facts were getting converted to strings before Puppet received them. And all strings, including the string false with air quotes, were true. So if the if statement, if it was based on a Boolean fact, it was always saying it was true. And experienced users knew that they had to do one of 2 things. And they weren't hard things to do. You just had to know to do them. You had to either compare the Boolean fact to the string true to find out whether it was true, or you had to use an add-on function that was available in the standard lib module, and that would turn a fact into a real Boolean value. But the problem was that every new user had to learn this the hard way, and there have been more new users coming in every year. So the epilogue is we fixed that. Not only can facts be Boolean now, they can also be arrays or hashes. And for example, we put now all of a machine's network information into one networking fact, which is kind of amazing because before that, if you wanted to do something with the full list of MAC addresses, you had to look up this fact that was a comma-separated list, split it on its commas, and use that to learn the variable names of a bunch of other variables to look up. Whereas now you can just iterate over the interfaces subkey of the networking fact, which is great. And now I just realized that I missed something. No worries. So moving on from the sort of big bang stuff, here's a group of stuff that maybe wasn't a big quality of life impact, but it was emblematic of the language's inconsistencies. Puppet had a lot of unpredictable stuff that would just make things worse in subtle and ridiculous ways, and we've tried to reduce a lot of that. So, for example, say you wanted to use a complicated regular expression in multiple places in a module. And the first thing you would think to do is stick it in a variable. And you're definitely not allowed to do that. You would get syntax error at /, which was super helpful. So regexps weren't actually proper values at all. They were just some sort of special magical syntax. But that wasn't where the weirdness stopped. So let's all collectively take a moment to remember the good old days when men were men, numbers were strings, undef was either nil class or a symbol, depending on whether or not it was in an array. It was chaos. By the way, shout out to Eric Delayan for reminding me that the inline template function is the fastest way to sort of immediately go to the shadow zone when it comes to data types. That's all fixed. Not only are regular expressions normal values with a normal data type, but there's a really predictable set of rules for transforming Puppet types to Ruby types and back, like undef is always just nil, and vice versa. We've cleaned up the sort of inconsistent identity of undef. We've added proper numeric types for both integers and floats that correspond to the exact same concepts in every other programming language. It's improved. Next, who remembers this guy? Left operand of plus is not a number. Does anyone know why that happens? Yeah, it's treating 20 as a variable. But 80 is not a variable. So if you just quote the first number in that expression, then it's fixed, yeah. Yeah, you add the string 20 to the string 80, because remember, all numbers are strings. We've cleaned up the rules around string interpolation a lot. This was basically completely undefined before, but now the basic trace is that we treat everything in the curly braces of an interpolation token as a normal Puppet expression, with only two exceptions. If it's a single bare word, then we treat it as a variable name. And if it is a bare word followed by a chained function call, then we treat that as a variable name. But that's it. Those are the only exceptions. And also, you can use functions in interpolation tokens now, which used to be illegal for no real earthly reason. When I was investigating this to document the Puppet language, I actually wasn't sure if expressions were supposed to work in interpolation or not, because it was so inconsistent that I honestly, it could have gone either way. Like, either expressions were working by accident, or else the support for expressions was just so busted that it would do things like turn the first term of an expression into a variable, or prohibit you from using functions, which were allowed, I think, basically everywhere else in the language. So yeah, here's a short one. The various comparison operators were added at completely different times over a really long time span. And the equals equals comparison one was case insensitive, and the in operator was case sensitive, and you just had to remember that. Now they work the same way, which is great. We decided to make them both ignore case, actually, now. And there were arguments for going either way. Every other language uses the comparison operator case sensitively, and we're kind of a weird outlier for not doing that. But at the end of the day, it would have broken more code to change the equals equals to match in. And also, I feel like I don't know anyone who can remember when CentOS needs to be capitalized and when it doesn't need to be capitalized. And at the end of the day, we are here to help people get shit done quickly. So the case-insensitive comparison stuck around. Next, Windows is pretty important, right? Windows uses a lot of backslashes in file paths and other places, but the backslash also happens to be the escape character in the Puppet language in strings, and we had a problem with single-quoted strings. In single-quoted strings, we have one escape sequence available, and that is a literal single quote by going backslash apostrophe, like that. But what about if you need a string that ends with a backslash? No? Not at all? How about if we, oh. It was impossible. There was literally no way to do that. So what you would do is you would give up, switch to a double quoted string, and turn every backslash into a double backslash. And that is now fixed in Puppet 4. And single quoted strings now have 2 escape sequences instead of 1. So you can double backslash for a literal backslash. But that bug kind of also drove home the fundamental limitations of our quoting constructs. Puppet, as you know, has the single quotes and the double quotes. But we didn't have anything like the Python triple quote or the standard here doc. So we added a third quoting syntax called here docs that are a little familiar from other languages. We did it in a bit of a weird way. You're going to wince a bit at the syntax, but it gives you total control over escapes, interpolation, wrapping of lines, and indentation, which I don't think I've ever seen in another language. It looks a little like this. It's really good for long strings like this one. You can see this example has, I'm going to try and point out some of the parts of this. The initial token with the @ sign and the parentheses is what configures the HereDoc. The double quotes around the token, the getConfig token, mean that interpolation is turned on. So you see that we're substituting some variables in there. And then the /L turns on exactly one escape sequence, and that's the cosmetic line break. So you see down here, we have one line that we are breaking up over 3 lines in our Puppet code to make our Puppet code more, just more usable in a Vim buffer. But because these lines end with a \, it ends up being turned into a single continuing line in the final output. And then finally, another feature that you're seeing in this is we have some cosmetic indentation turned on by showing this pipe character where the indentation stops. So this indentation that helps set off this large string from the rest of the surrounding Puppet code content. So it's easy to just visually see, you know, all the indented stuff is just this config string. Ends up getting trimmed off, and in the final code, that's all flush with the left of the buffer. You can also use HereDocs for small, simple strings that just do things that Puppet's normal quoting constructs don't like. So for example, here, you see that we're trimming off the final line break with this minus sign. We have interpolation turned off. We have escapes turned off. We have a string that ends with a \, and we don't have to do any escaping of those backslashes at all. So that turned into a bit of a digression, but I really love HereDocs. Even this weird kind of new format that I'm still having to look up a little bit every time I need to use it. The amount of control it gives you is indispensable. And plus, the ability to embed large, complex, multi-line strings alongside your Puppet code is new. And I think it's a little bit game-changing, honestly. Like small config file text, small templates. And I feel like there's a lot of stuff in a lot of modules that's just under that threshold where you don't get any benefit by putting it in a separate file. By putting that kind of stuff right alongside the code that uses it, I think it makes code more readable and just faster to understand for the colleagues that have to work with it. So there's my little pitch for HereDocs. I like them. Okay, last one in the section. Who remembers this guy? This is only the setup. The punchline's coming in just a second. Yeah, yeah, that was totally legal. You could name a class, but then you had to make sure that you quoted class whenever you were using it. And if you didn't do it right, it gave you syntax error at class at that 5th line where we used include, which is great. This was one of my favorite slides from 2013. I loved it. In Puppet 4 now, this is now totally illegal, and it gives you an error that says, get this, class is not a valid class name at the place where you defined the class. That's actually bigger than it looks. Because to give you an error message that made honest-to-God sense, instead of just like throwing up our hands and like doing whatever, like you saw before, we needed a much more structured and granular understanding of literally every part of every expression in the language. And that required a vastly improved parser with better control over how expressions are defined and governed. And I think the upshot is, like, if we had wanted to just fix that dumb error message, we still would have literally had to rewrite the entire language. I think this is kind of emblematic of the sort of wide-ranging improvements that come out of this language rewrite effort. It's just that the language is now so much better defined that fixing things that would have been really difficult for really stupid reasons is now just completely within arm's reach for us. So that was a group of problems that were all kind of silly, that you aren't going to encounter every day. But I think they show a lot of how Puppet 4's improvements are part of this wide-ranging effort to bring consistency to the language. So in this final section, I want to talk about some stuff that wasn't actually broken before, but was just kind of fugly. Things that weren't the nicest way of doing things or were kind of a bummer. These aren't the kind of headlining cracktastic WAT misfeatures that featured in that old comedy bit from a couple of years back, but they've just made the language tedious. And I think our fixes for these are going to have an even bigger positive impact than some of the stuff that came before. Here's something that's been common for a long time in reusable Forge modules. Let's zoom and enhance to show what's going on here. There's a bunch of these validate underscore something functions in the Puppet Lab standard lib module. And they served a really important purpose because if you were writing a big module that was going to be reused by a lot of people with a lot of different needs, you really had to validate the inputs of your classes and define types. And you really had to provide useful feedback if those inputs were pathological, because otherwise your module was going to be difficult for people to use, but more than that, it was going to be difficult for you to respond to bug reports. And if you're treating module development as software development, that was a killer. So these were super popular, but just look at all that. It's just a waste. They're duplicating the whole parameter list. They're separating the validation from the place where they're declared. So when we had the chance to do this, we built in parameter validation with the new data type syntax. You put the data type restrictions right where the parameter is declared up in the parameter list. It's right next to the default value for that parameter, if there is one. It's extremely flexible. You can see that there's some basic stuff here like array and string and integer, but you can also do things like pattern, which is a string that matches whatever regular expression or list of regular expressions you provide it. Or you can do, you can expand the array type to specify this needs to be an array of strings and it needs to have at least one element in it, right? There's a lot of documentation for this in the Puppet language reference on modern versions of Puppet, but I think this is a big deal. Being able to do this parameter validation in a way that's perfectly readable not only makes the code itself easier to read, but it enables things like Puppet strings to extract information about the types and present it in generated documentation. By the way, shout out here for Puppet strings. If you haven't checked this out yet, it is at version just barely not version 1. It is good to go and ready to use, and it is sweet. All right. Next, does anybody remember any of these things? Starting with the old Ruby DSL, or anyone who's made a defined type that does almost nothing but declare a single resource just to work around some kind of shenanigans, or the create resources function. Let's get a show of hands of anyone who's had to use any of those to fix something weird. Yeah. These all look pretty different, but I believe that these were all three just attempts to work around Puppet's lack of simple loops. Oh, by the way, if you're not familiar with create resources, it worked a little bit like this. The idea being that you used some kind of external tool to generate an intermediate data format that kind of looks like a resource. So you can see here in this hash, we have the keys are usernames, and the value of that is a hash of attributes for that resource type. Then you would bring that into Puppet, probably with Hyra, and use create resources to convert these pseudo resources into real resources. It was very flexible. It had, it solved a lot of really sticky problems, but it was basically impossible to debug. And it just, I feel like you knew you were sinning every time you brought it out. Unless you were Dan Bodie. Shout out to Dan Bodie. He did some amazing things with this stuff that was years ahead of its time, but again, create resources just kind of, you have to accept the pain when you go there. All of these workarounds were clumsy. 90% of the time, all that was happening was this. you had a relatively simple data structure that did not look like this complicated thing. It was just like an array of names or something, or like I don't know, something. And you just wanted to create a varying number of resources based on that data using a simple set of rules, and that was it. And you had to go through all this rigmarole. But now this is it. You can specify a block of code to repeat for each item in a list. You can tell Puppet where the values from the list should go, and it works. This is, holler if you can't see what this is doing. It's pretty simple. I think for a lot of the people who switched to the feature parser early, and you were hearing from them like a year or two ago, this was the headline feature of the feature parser. It was the thing that justified almost any hassle just to be able to do this. For the rest of us, even if it's not a headline feature for you right now, I think it's going to be a relief the next time you run into a situation where you need it. And if you're writing Puppet code at all, that's going to happen in a couple of months, no matter what. And finally, I think probably the most embarrassing thing about Puppet for the last couple of years is that you had to learn Ruby just to write a damn template. Templates are pretty important. They are, I think there's probably somewhere around like the 6th most important thing that you need in order to manage anything in real life with Puppet. And once upon a time, back in like 2007 or 2008, it was a fact that most of the people picking up Puppet were Ruby heads to begin with. So Ruby's ERB template was really a big time saver. It was already familiar to these people, and they didn't have to learn another thing. Those days are long gone. I think for most of today's new users, and actually, could you raise your hand if you're in this group, having to learn a whole separate programming language is what ERB meant. Yeah, oh God, yep, I'm seeing at least a third of the people in this room who came to Puppet without already knowing Ruby and had to jump this really pointless extra hurdle. The best part is that ERB wasn't even a great match for Puppet's internal models and objects. You had to use things like the scope object to call a function. You had to convert Puppet data types to Ruby ones, which, like I said, that's better now, but it was real bad in Puppet 3. You had to use a mix of local variables and instance variables. It was janky. Bare word functions. Yeah, if anybody has not used Ruby before, the question, how do you tell the difference between a function call and an instance, or sorry, a local variable, is you don't. Anyway, Puppet 4, welcome to Puppet 4. We introduced a new template syntax, which would have been super overkill in like 2007 or 2008, but this is great. If you're looking at this right now, you can see that we had to add a few tags to indicate the difference between comments, actual text that should be in the final output, and Puppet code. But once you learn those tags, it's just Puppet inside. You can see a variable reference that just looks like a variable reference. You can see control structures like this unless or if statement that use the normal Puppet if syntax. You can see comparison to data types that use Puppet data types. And I believe you can see, we don't have iteration in this example, but iteration constructs work the same way they do in the Puppet language as well. I believe this is huge. I think it fills an awkward gap in our ecosystem that's been frustrating people for years and has been egg on our face. And I think new users will be able to understand this syntax and just hit the ground running with it, doing useful things so much faster than they could with ERB. Not only that, but if you remember what you saw earlier from the HereDocs slide, I think there's probably also a lot of cases where you don't even need to go into an EPP template. If you're just substituting some values, you can probably use a HereDoc with interpolation turned on and just put an arbitrarily large config file right there. So that was the final item, and it's the end for now. So I want to say thank you for coming to PuppetConf. Thank you for coming to my talk. I hope you enjoyed it. And to close out, I want to say something I said a few years ago in my WAT talk at the very end of it, is that WAT brings us together. That is to say, talking with other people about the weirdest shit in your field is somehow more productive than trying to work in a completely serious manner. The joy of fucking around with broken stuff, I think, encourages us to learn more and to teach more, and it helps us move useful knowledge from the people who have encountered it to the hands of the people who can do something about it. And this is the result. Less than 3 years after that talk, we have a really comprehensive revision of the language that fixes the worst stuff we used to come together and bitch about, and does even more besides. Thank you for being here. Thank you for sharing your own bizarre nonsense with me after that talk. And thank you for being part of the continuous process of making the tools we rely on better. Does anyone want to talk about anything? Yeah, question back there in the, I believe you have a bandana on, but I can't tell with that light.
Yes, it is a bandana, and it even has a map of the Caribbean on it.
Hey-o.
I'm that guy. So I'm still running a mixed environment. I've got Puppet 4 Masters running on Trusty, and then I've got a bunch of Puppet Agents 343 on Saucy, Don't Judge. Mm-hmm. And so some of the stuff that I'm seeing here, is this all compile time stuff that the agent won't choke on, or are there things that I can't do with my 3x agents that we saw here?
Let me think. This is all compile time stuff with one exception. When you're running the 3x on your older machines, I assume you're running like 3.7 or 3.8?
Nope, 3.4.3.
Gosh. Okay, well, here's the deal. Using real data types with facts was that was a agent side setting up until 4.0, and we couldn't default it to on until a major version boundary because that would have broken some stuff. But the setting was available, so if you change the setting to true on, hold on a second, I'm gonna break.
I would love to know what that setting is. Stringify facts?
Stringify facts. What I was going to do is bring up my language reference here and see if I can find the version where that started working. You said 3.4?
3.4.3 specifically, I'm sorry. It's so terrible.
3 without the version number? Want to go to...
That's right. Oh, God. Thank you. It's been too long. If we pop open the release notes, stringify. Oh, that's sad.
I appreciate wandering into the weeds for me here.
Frick. Okay, well, so here's what you're going to have to do. You're going to have to wait to take advantage of structured data facts that are hashes or arrays until you've managed to get those nodes migrated.
Okay.
And for Boolean facts, until you're able to get those nodes migrated, or at least migrated to a newer 3x that has the stringified facts option, you're going to need to do this idiom, let's see, new file, blow up, string to bool, parentheses, quote, fact name, quote, on parentheses. That'll turn a real Boolean fact into the same real Boolean fact, and it'll turn a stringified Boolean fact into a Boolean fact. So that's kind of your shim until you can get up to a point where your agents can stop stringifying facts.
Okay, thanks.
Yeah.
So this ultimately, sorry, so used to eat the mic at the office. This might be a better question for Henrik ultimately, but so the new templates are awesome. I'm curious what you think about the one thing about them that pains me to no end, which is the fact that you have to do the goddamn little curly brace to open in like inside a tag at the end. It looks awful and it's confusing when I try to teach it to people.
Oh, is it?
Yeah, like because they don't even see why it's hanging there. You know what I mean? Does that strike you? Like, have you?
So,
Why that?
Why that? I mean, I think the real answer to why that is because it is just the Puppet language under the hood, and Puppet doesn't have a syntax that lets you omit the curly brace. That's not a good answer for why it should be that, though. That's just an answer for why it is that. Yeah, let's see. Would there be a way that would make sense to get rid of that? If we would have to change the syntax. We would have to introduce some new syntax that let a line break stand in for it. Or we would have to allow EPP tags to insert implied syntax when they close, which would be hard to explain.
Even just a loop that could end with the word end.
Yeah.
Just be more readable and easier to see what's going on.
Yeah, we would have to change a couple of things. We would have to change the conditional data structures, the conditional syntaxes, because those are special expressions. And we would have to change the lambda syntax to both allow sort of do and end or whatever.
Maybe not worth it, just
On the other hand, maybe. So I would bring that to Henrik.
I just wanted to remember everyone that PHP does that. So no, like it has two different syntaxes for if and while and whatnot. So
Oh, guilt by association. I think that's the end of it, unless someone else wants to throw a hand up. All right. Well, yeah. I'll be around for the remaining 20 minutes at the conference, I guess. Thanks again so much for coming out, and have a nice rest of your Friday.